Hey everyone, and welcome back to the channel. Let me ask you a question. How much of your day as a cybersecurity professional is spent just trying to make sense of the data? Forget the Hollywood image of hacking for a second. The reality is often you, a terminal, and a mountain of logs that you need to pore through to find out what is bad. You might be drowning in a sea of different formats. Apache logs, Windows event logs, JSON outputs from an API, CSV files from a threat intelligence feed, and your job is to find the single malicious event, the needle in that haystack. For decades, we've relied on a legendary toolkit. Bash, grep, awk and sed, all your best friends. They were powerful, no doubt, but they were designed for a different era, an era of plain text. They treat everything as one long string of characters. Think of it like trying to find a specific book in a library, where all the books have been shredded into individual words and dumped into one giant pile. Sure, you can find what you need, but you have to painstakingly piece it all back together. That's the issue with working with plain text. What if I told you there was a better way? What if your command line understood that log files have columns, that JSON has key value pairs, and that API outputs have structure? A modern command line built from the ground up to handle the structured data that defines our world today, and that you get from your security tools. Well, there is, and it's called Nushell. In this video, I'm going to show you why Nushell isn't just another shell. It's a powerful analysis tool that you can use as a secret weapon in your cybersecurity arsenal. We'll cover what it is, why it's a paradigm shift from traditional shells, and walk through real-world examples of how you can use it to investigate threats faster and more efficiently than ever before. Stick around because this might just change the way you look at your terminal forever. So what is the magic behind Nushell? The big idea is simple, but revolutionary. Everything is data. Not just text, but structured data. While Bash sees a wall of text, Nushell sees a table with rows and columns. When you run the ls command to list files, you don't get a string of file names. You get a table with columns for name, type, size, and modified. This might not look like a big deal, but it's a game changer. It's the difference between getting a raw text file and getting a fully functional spreadsheet. Because Nushell understands structure, you can immediately start working with this data. Want to see the 5 largest files in the current directory? Simple. No parsing, no complex awk or sed commands. You're manipulating objects, not just text. This concept of a pipeline of objects is what sets it apart, and it has built-in support for the formats we use as cybersecurity analysts every day. You can open a JSON file and it's instantly a queryable object. Open a CSV and it's a table. No more fighting around with JQ, syntax, or awk field separators just to pull out a single piece of information. So this might seem like a big deal for data analysis, and it is, but it's even bigger for cybersecurity. And this boils down to 3 things. First, clarity and reduced cognitive load. The tabular views are clean and easy to read. When you're in the middle of a high-stress incident, staring at a screen for hours, your brain gets tired. Cognitive load is a real factor and can lead to mistakes. Nushell's clear output helps you spot anomalies faster because you aren't burdened with a wall of text or trying to build complex commands. Second, power and simplicity. The commands are intuitive and composable. You want to find processes using more than a gigabyte of memory? Easy. The command reads almost like an English sentence. This means you spend less time trying to remember arcane syntax that was popular in the 80s, and more time focused on the question you're trying to answer. Then finally, Nushell is truly cross-platform. It works the same on Windows, Mac and Linux. For security teams that operate in mixed environments, this is huge. It creates a unified language for your team's data analysis tasks. Alright, enough talk. Let's see it in action. I've set up a few common cybersecurity scenarios to show you how Nushell can blow traditional tools out of the water. Alright, so first up, let's take a look at analysing an Apache log file. Our goal is to try and find an IP address in here that's trying to access a sensitive part of our website, say the login page, and how many times it's trying to access that specific login page, for instance to detect a brute force attempt or gather some intelligence about a threat actor's infrastructure. So let's take a look at that log file. Here you can see that it is just a plain text file. There is no structure and there's no parsing. Now we could parse it using a mix of maybe awk, sed, grep to find the answer we're looking for. But let's try the Nushell way. First we'll open Nushell with the new command. And now let's take a look at that file again. Same text file. But now let's use the parse option to try and get a structured output. That's great. So here I've used the open command to access the access.log file, and I've piped that into the parse command where I can define my own custom parser to extract the data I want from this file. So if we look at the plain text of the file, we have the IP address. Then we have two dashes, a timestamp, the method used, the URL accessed, the protocol, the response code, the size, we have the domain, and then finally the user agent. So I've created a parser that extracts those key details and will automatically add them to a table where we can query them. It's kind of similar to how you could parse a file using something like grok. So I've extracted this and now I've just piped it into the head command to get the first 20 lines. As you can see, it's in a nicely formatted table. Let's take a look what that all looks like though. Here you go. So I get the IP address, the timestamp, the method, then the URL. Now say I don't want all these columns because you can see that we're missing a few off the back here. So let me use the select command to define what columns I want, similar to like if you're querying using SQL. So we'll pipe it in, and here you go. Now I just select the IP, domain, and the URL, which is a bit squashed, but that's okay for now. But more importantly than just nice pretty output, what can this allow us to do now we've got this structured data? Well, perhaps we could search for URLs that contain the word login. Here I'll use the where command as a filter, and the equals sign tilde sign is similar to the like command in SQL. Awesome. So these commands we've got back, we can see that login is in the URL. Now, and we can see the IP address of what is trying to access that sensitive area. Now let's do some aggregations. Let's maybe group by IP address to see what are the IP addresses and URLs they're accessing. So we'll pipe that into group by, and we'll group by IP. Here I performed an aggregation and we've grouped it into IP and the URLs attempted. Here we see there's two IP addresses. We have this 10.10.0.078 and this 10.255.254.2 address, and the URLs they're trying to access. Say this is our sensitive area we don't want them to access, and these are malicious IPs. Okay, now maybe we want to figure out how many times each of these IP addresses have accessed this. Here it's easy, we can just count, but in a real log file you're going to have thousands if not millions of individual lines to count. So let's use some Nushell magic. Here I'm going to pipe it into the transpose command. This creates a table that we can then loop through. So because Nushell is a programming language, we can create a simple for loop to loop through these two columns and count how many attempts are made by each IP address. So we'll use those column names we saw previously, and then use the length command, which is similar to the count command in bash, to count how many items are in each of those group by columns. We'll then pipe it into the sort command, and we'll sort by the number of attempts in reverse order to get highest to lowest. Awesome. We see that 10.10.078 address has the most attempts with 20. Now, just walking back through this command, what we have done here, we've opened the access.log file, parsed it into a structured format so we can manipulate it. We've selected two of the columns where the URL column contains the word login, or is like login for SQL fans. And we've grouped it by IP address as our aggregation. We've used transpose to turn that list into a table that we can then iterate through using the each command. We then iterate through it, and we have an IP address and an attempts column, and we set the previous column, so column 0, which is that group by IP address, so there's individual IP addresses, and the column 1 column, which is the individual items associated with those IP addresses. We pipe that into the length command to count how many attempts were made, so how many times that URL popped up, and then we sort by attempts to get the descending order with the reverse flag. So this gives us the number of attempts for that IP address to access a URL that contains the word login, and we've sorted it to give a nice structured output for our analysis. Simple. So let's say that we've identified this 10.10.078 as the malicious IP address. Well, we can walk back a few steps, and maybe we just want to get where that IP address is being seen. So we'll type IP here, and then we'll equal it to that 10.10.0.78 IP. Here we see all the attempts it has made and the URL addresses it's queried here. Again, using that where command to get the structured output. Now we could perform even more data manipulations on this. We could use the various columns or filters provided by Nushell to extract more data. The important point here is that we've gone from unstructured text-based data that's hard to parse into a structured format that we can then perform data analysis on using Nushell's various tools built into the platform. Like I said before, Nushell isn't just for Linux or Mac machines. You can also use it on Windows. As a blue teamer, you're often investigating Windows security logs, like a failed login attempt with the 4625 event ID. You can use PowerShell to collect these Windows event logs from the security channel, convert them to JSON, and then use Nushell to manipulate this data and find these malicious login attempts. This could be great for an investigation scenario, like performing incident response or digital forensics. So let's see what this looks like. To get these logs, you need to be running as an administrator, so I'll open the terminal application. This will land me in a PowerShell prompt. So let's open Nushell, and let's run a PowerShell command to get those Windows event logs. So here, I use PowerShell with the -C option to run a command. I use the get win event commandlet with the log name security to get those Windows event logs from the security channel. And then I use the convert to JSON commandlet to convert those raw logs into a JSON format that we can parse using Nushell. And then pipe this output into the save command to save it as a JSON file. Now it's going to take a bit of time because it needs to pull those event logs, convert them to JSON and save it. So maybe get yourself a coffee. Awesome, that command's finished up. So let's take a look what that security log looks like. So we can just use the open command. And because it's in the JSON format, Nushell will automatically parse it for us. Perfect, we got a table with all those security event logs in. But as you can see from the output, it's a little difficult to read. So let's just get the first record and see what we're dealing with. With JSON data, we can use the get command and we'll select the first record. So scrolling up, let's see what's included in that record. We have an ID 4624, successful login. We have some data about it, so we see it's a successful login. Give some properties, and then we get the message. So it says the account was successfully logged on, security ID, name. So let's just get back all those event logs with a event ID of 4625. So that'd be failed logins. So we can search this data with the where command. We can use ID to access the Windows event ID. We can search 4625. And now we'll just select the machine name and the message. Great. So it looks like we get back 3 failed logins. So taking a look at this first one, we have a failed login on this machine. We have the account name, which is my account, failed logon. We have the reason, unknown username or bad password. So let's pipe these into the length command to get a count of how many we actually got. We got 3. Again, we can pipe this, and perhaps we just want to get that first one we looked at. So we can use the get command again, get that first record, and all the details about it. This is great for an investigation, as we can now parse the Windows event logs directly on the command line using a structured format. Now we could perform other actions, so we could group by some of these fields. We could dig into these fields deeper. We can use all the data manipulation tools in Nushell at our disposal. Okay, for the final example, picture yourself working in the Security Operations Center. You get word through from your threat intelligence team that there's some malicious IP addresses you have spotted and you want to search your logs for them. Well, these malicious IP addresses have been uploaded to a CSV file. We have the IP address and a reputation, and we want to find this IP address in our log files to see if we've been impacted by this threat. So how can we go about doing this? Using Nushell. Well, like I previously said, Nushell is a programming language, so that gives us access to variables. So let's create one here. We'll use the let command to create a variable called block list, and we'll open that iocs.csv file directly into this variable. This will let us query it in our later commands. Now we want to go back to that Apache access log and search for this IP address, although it could be multiple IP addresses in that CSV file within our Apache logs. So let's use that previous command where we open the access log file. We use a custom parser to parse it into a structured format we can query, and then we can pull back that IP address and URL column. Now, how can we use this IOC list with this structured data to find if any of those IPs in the list are in our log file? We can use the where command again, and we can query that IP variable, and we can use the in command with our block list variable that we created earlier and the get IP address. So what does this command do? Well, here we're using where to filter for specific fields, and we're filtering on the IP column. We use in to search through a list for a specific IP address. Where do we get this IP address from? Well, it's from this block list variable, which we previously created with the command let block list. So we create a variable, and then we open that iocs.csv file into this variable. So this variable will contain this CSV file. Now Nushell automatically parses CSV files into a table, which is handy for us because you can extract data from a table using the get command. So say here, if I use $ block list, pipe it into get, and then I get that IP address, so that IP address column here, it'll give me that malicious IP address. So all this command does, it uses the block list variable and gets the IP addresses, so a list of IP addresses that we then can use with the in command to search through with that IP field. So I run that command, and here I get a list of every time that IP address has popped up in this log file. So this malicious IP address and how many times it's popped up. Here we can see 455 times. That's awesome. We had 2 completely different log sources, a raw text log and a CSV file, and found concrete evidence of a threat. This is very powerful. Trying to do this with traditional shell tools will be very challenging indeed. Nushell's powerful built-in analysis capabilities allowed us to do this. So you're probably thinking, these scenarios look great, but what if I don't know what data manipulation I want to perform in Nushell? That's where the explore command comes in. So say we have this file again, and we open it and we parse it, but we don't know what data manipulations we want to perform. Well, we can pipe it into the explore command, and explore acts as a table pager, like less, but for table structured data. It allows you to see the data you work with and try out data manipulations on it. You can try out filters with the where command or aggregations like group by. So here I've opened it, and you can see it looks just like the less command, maybe a little prettier. Now if I type try, as you can see at the bottom, it opens up a toolbar where I can try my data manipulations. So I could say where IP equals 10.10.0.78, and I'll get that data back. So here is, you probably didn't see a change, but here all the IP addresses are 10.10.0.78. Now I could also press escape to get out of that, and I could also go back and I could perform a group by, so we could do that group by again. Let's group it by IP. Here I can see I've got 210 rows for that 10.10 IP, and I've got 456 rows for that other IP address. Now I use the down command to jump into that data, and I could explore it further. So let's look at those 456 rows. So I've jumped in, and now in this group by clause I've got all these IP addresses for this 10.255 IP address. Now I could go back by pressing escape twice, and I could explore another IP address. Again, I could group by something else. I could group by URL, and here we have all the different URLs. So I jump into this data using the arrow keys, escape key to go back, and the enter key, and I see I've got 8 rows here for this URL, the slash, the home URL. Awesome. I could put any filter I wanted in this bar to query the data better and explore it in an interactive environment. That's great. Now, say if I was here, and I'll jump to this home page again, and I'm on this specific record here. Now if I escape out of it, I get nothing back in my shell, right? Data's gone. But if I use the peek option with Explore, and I perform those actions again, so I'll type try to open that Explorer view, and we'll group by URL again, and we'll jump down to that home page with 8 rows in it, and we'll jump down to this record once more. Now if I quit out, so I can type :Q, classic Vim, when I escape this time, the data that I was highlighting through that explore command is automatically pasted into the terminal. As you can see, Nushell isn't just about making your terminal look prettier. It's a fundamental shift in how you interact with data. It's about moving from a world of unstructured text to a world of structured data. It gives you a powerful, intuitive, and consistent way to query, filter, and reshape data from virtually any source, turning your terminal into a truly interactive analysis environment. For cybersecurity, this means less time fighting your tools and more time fighting threats. It means faster investigations, easier scripting, and clearer insights. You can pivot your analysis on the fly, correlate disparate data sources with ease, like JSON versus CSV, or TOML, or YAML, and ultimately arrive at the answer faster. Whether you're a pen tester parsing scan results, or a forensics expert analysing logs, or even a security engineer automating tasks, Nushell deserves a place in your toolkit. So my challenge to you is this: download it, install it, it only takes a minute, and start exploring from there. I promise you, once you start thinking in structured data, you'll never want to go back. So that's all for today. If you found this video helpful, hit that like button and consider subscribing for more content on the tools and techniques that can level up your cybersecurity career. Drop a comment below and let me know what you think of Nushell, or if there are any other tools you'd like me to cover. Stay safe, and I'll see you on the next one.